Hello, geometry ladies and gentlemen. This unit is all on the shape of quadrilaterals. And as we learned a little bit ago, quadrilaterals consist of a lot of different subsets of shapes. And that first subset we're going to look at is parallelograms. So what you're going to need today are your notebook, a foldable, your pen or pencil, and a calculator if you so wish. This is what your foldable should look like. So if you haven't gotten the chance to fold or cut appropriately, this is what it should look like, and then you'll glue on the back side of what is shown in this picture. Before we dive into the four theorems about parallelograms, let's first look at the definition of a parallelogram, and this is at the top of your foldable. A parallelogram is a quadrilateral with both pairs of opposite sides being parallel to each other, which is why we can understand the name of the type of shape, right? If two pairs of the opposite sides of the shape are both parallel and it's a type of quadrilateral, then we have a parallelogram. So each one of these flaps or each one of these four theorems are additional properties that a parallelogram has. So if we flip to example number 1, the theorem or the property that's explained here is if a quadrilateral is a parallelogram, then its opposite sides are congruent. So not only are the opposite sides parallel, they are congruent to each other. We know that now. So these two sides are congruent, these two sides are congruent, these two sides are congruent, and these two sides are congruent. So that's going to be able to help us set up some equations to solve for the variables, which is exactly what we're going to do in part A and B. So in this first shape or first parallelogram in part A, I'm going to set up 18 equal to 3x because that's what it means to be congruent, right? Now all I have to do is divide by 3 to solve for x. So that gives me x is 6. Now let's do the other pair of opposite sides. We have 22 is equal to y minus 5. Now all we have to do is add 5 to both sides. We have 27 is equal to y. Now moving on to shape B or parallelogram part B, we have the top and bottom pair. Let's do those. We have 28 is equal to 9x plus 1. Subtract 1 from both sides. We get 27 is equal to 9x. Divide by 9. Divide by 9. 3 is equal to x. And then if we set up the other one, which is 11 is equal to 2x minus 5, we add 5 to both sides. Here we get 16 is equal to 2x, divide by 2, divide by 2, x is equal to 8. So that's how we would apply this theorem when we know that parallelograms opposite sides are congruent. We can use that to set up equations and solve for the missing variable. Moving on to the next theorem or property. So if you open the flap that says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So that's another thing that we can set equal to each other, and then we can solve, right? So we're saying this angle in number 2 part A is equal to this angle. So my equation then is going to look like 139 is equal to 7x minus 1. Add 1 to both sides, we have 140 is equal to 7x, divide by 7, divide by 7. Here we get x is equal to 20. Now moving on to number 2 part B, this angle is congruent to this angle, so I can set up 6x minus 1 is equal to 7x minus 10. Remember, we have to move all of our x's to one side, so it doesn't matter what you do. You could either subtract 6x like I have done, or subtract 7x. But now we get negative 1 is equal to x minus 10. Add 10 to isolate our variable x, and here we get x is equal to 9. So there are some more examples of how we can set up and solve. Now let's open the flap that says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Wow, that's a lot of vocab that we haven't talked about in quite some time. Remember, consecutive angles are angles that are next to each other. So this angle and this angle are supplementary, which means they add to 180 degrees. So 9x plus 135 is equal to 180 degrees. So here when we solve, we subtract 135. We get 9x is equal to 45. Divide by 9, divide by 9. We should get x is equal to 5. So now on example 3, part B, there's lots of different ways we could set this up, but we both have to solve for x and y. We could set these two equal to each other, right? But then we don't have same variables, which would be hard to solve or impossible to solve. So let's use the theorem from this flap that consecutive angles are supplementary. So I'm going to use the top two. 120 plus 5x plus 20 is equal to 180. Okay, so we have to combine like terms first. So 120 plus 20 is 140, plus 5x is equal to 180. Subtract 140 from both sides. We should get 5x is equal to 40. Divide by 5, divide by 5, and here we will get x is equal to 8. So we could do the same for y. We could say 120 plus 8y plus 4 is equal to 180. But I think now that we know that x is 8, we can plug it into here to find this value and set that equal to 8y plus 4. Again, it doesn't matter which way you set it up. There's going to be a couple different ways that you can set this one up. So if x is equal to 8, 5 times 8 is 40, plus 20 is equal to 60. So this angle right here is equal to 60 degrees. So then we can set up 60 is equal to 8y plus 4. Subtract 4. We get 56 is equal to 8y, divide by 8, divide by 8, and we should get y is equal to 7. Again, if you would have said 120 plus 8y plus 4 equals 180, you should have gotten y is equal to 7 either way. And our last theorem or property says, if a quadrilateral is a parallelogram, then its diagonals bisect each other, which means that this diagonal and this diagonal, where they cross, cuts each other exactly in half. So what we're saying is this piece is congruent to that piece, and this piece is congruent to that piece. So that's going to be able to help us set up some problems. So let's set up 14 is equal to 5x minus 1, add 1 to both sides, right? 15 is equal to 5x, divide by 5, we should get x is equal to 3. Now we can set up the other one on part A, and we have 18 is equal to 9y, divide by 9 on both sides, and we get y is equal to 2. Okay, moving on to the next picture. So the diagonals bisect each other, so this piece is congruent to that piece, and this piece is congruent to that piece. So let's set up the red one. We have 7y plus 2 is equal to 10y minus 7. I would subtract 7y from both sides. I just like to keep my variables positive in that way. Add 7 to both sides to isolate that variable. We get 9 is equal to 3y. Divide by 3 on both sides. We should get y is equal to 3. And then let's set up the last one. 4x plus 4 is equal to 5x minus 8. I would subtract 4x from both sides. That's going to give you 4 is equal to x minus 8. Add 8 to both sides, and we get 12 is equal to x. And that is all I have for you guys, so try to remember these properties. They don't have any specific names, but knowing these 4 properties about parallelograms will definitely help you in the long run for solving, and they will come in handy, so make sure to have them in your back pocket. And I will see you soon.